Welcome, everybody, to episode number 52 of Underserved. Today in studio, I have Morgan Creighton, a senior Scala developer at Syrinx. Let's get started.
Welcome to this week's edition of Underserved, the podcast for the rest of the tech industry, where we focus on stories of tech industry leaders, their insights, and their lessons learned. And now, your host, Andrew Jelina.
Morgan, thank you so much for coming down today to record with us.
Andrew, the pleasure is all mine. I'm so happy to be here in our wonderful studio, and I hope I'm interesting.
Oh, I am 100% confident you will be. So tell me, Morgan, way back in the day when you were a kid, what got you interested in science, technology, and computers in particular?
Well, I've always been interested in science. I knew from a young age I would have something to do in science. You know, my family and I watched Carl Sagan's Cosmos when I was a kid. And like so many people, he showed how cool, how inspiring, how interesting and wonderful science can be. And I knew that I would someday be, if not a scientist, maybe a computer scientist, maybe a computer engineer. And I feel very privileged to have been able to realize that dream.
So you're watching Carl Sagan, and what was the first computer that you remember programming on?
Well, back in my elementary school, we had trash 80s, the old Radio Shack Tandy machines.
Yeah, buddy.
And I learned how not to program, I guess, and I learned a little BASIC. And there were no disk drives that we had. We had literally a tape cassette recorder. And I can remember playing around with the computer after school one day, hey, if this really is a tape recorder, it should be able to play sound. So I remember writing programs trying to make that tape recorder play recorded sound. I said, hey, I'm going to make the computer talk. And everyone said, kid, you can't make the computer talk. I said, well, let me try. And I think there's a kind of fearlessness about that where people say, oh, that's not possible. And maybe it isn't possible. But, you know, when you're a kid, you have that bravery, you try things, and maybe that's the best way to learn.
Did you get it to work?
Between you and me, marginally successful.
Very good. But didn't you end up getting tossed out of the computer lab once upon a time?
Yeah, we had to mention that. When I went to high school at St. John's, we didn't have the Trash 80s. It was another computer. I can't remember what kind it was, but it still used BASIC. And, you know, in those days, to figure out how things were working, I'd go to my own line as a kind of an active breakpoint. If you can imagine, program executes so far, and then you go to yourself. When I did that on the Trash 80, everything was fine. I could Control C out of that. But in the high school computer, it locked everything up. So I got thrown out of the computer lab for messing up the computer and forcing it to be rebooted all the time.
Sometimes you got to move fast and break stuff.
It's true. It's the way to learn.
So you must have done well in high school because you end up going to Harvard.
I did well, and I went to school. I wanted to study physics, so I pursued physics as an undergrad and really had wonderful experiences there. And I should mention, while I was there, I was studying. Normally I studied in the library, but some strange reason I was studying in my dorm, and the phone rang. My friend Ben called me. He said, Carl Sagan is in the Science Center. You got to come down and see him. And I'll always be grateful to Ben, and whatever quirk of fate had me answer that phone. So I got to meet my childhood hero for just a few minutes when he was speaking about the search for extraterrestrial life. I was too nervous at the time to say anything to him, but my friend Ben, who was a lot braver than me, went to Carl and he said, Dr. Sagan, can I have your autograph? And he said, sure. Just the way I imagined he would have said it. So that was a wonderful experience. And, you know, you think of all the problem sets you suffer through in school and all the work that you do. And the thing probably that first comes to mind when I think of my Harvard experience was that moment getting to meet Carl Sagan.
That's really cool. Now, you're at Harvard. You're surrounded by like the top X% of people from everywhere trying to get in there. A lot of folks say when they're in an environment like that, they feel like they have imposter syndrome. Is that something that you felt too?
I certainly felt like I had imposter syndrome, and I was completely convinced I was the only person that had imposter syndrome because everyone else was super smart and wonderful and talented. And what's strange is that, many years have gone by since then, and I've rekindled some friendships with people over Facebook and other things since then. And they say to me now, oh yeah, I was totally intimidated. I had imposter syndrome too. I just couldn't let it show. And I thought, oh, I wish I had known that then. I thought it was just me.
Well, for all you students in university, take note. So you graduate out of there. What was your first job?
Well, just before I graduated, I worked for the Harvard-Smithsonian Center for Astrophysics because I was a physics major, astronomy major at the time. And funny thing that happened was we were working on a Balloon-Borne X-ray telescope. So to see X-rays don't pass through the Earth's atmosphere very well. So you've got to put your telescope up either in orbit or on a high weather balloon. We had a Balloon-Borne telescope. And there was a presentation of all the work that we were doing. Now, I was just the lowly undergrad working on a big project. And a very smart graduate student and I were there to participate in a presentation to the public of all the interesting work that was going on. But it was so popular with the public that when we got to the amphitheater to share our story, it was packed and they wouldn't let us in. So we weren't able to give our own presentation.
No way. Who gave it then?
Well, the professor really was the person who gave the presentation. But afterwards, he found out that they wouldn't let us in because of the fire rules. And he said, oh, you guys were the presentation. What happened? But, I got to work with materials. We did programming, painted stuff, bolted stuff, had to solve problems that nobody had solved before. And I thought, oh, this is really cool, And a good friend of mine, Rob, in college said, when you solve a physics problem, Isaac Newton solved it hundreds of years before you did. Your professors aren't very impressed. But when you solve an engineering problem, you might be the first person in the world that ever solved that problem. And I thought, yeah, maybe that's what I want to do. Maybe engineering is more for me.
And so is your first job out of university in engineering?
It is. I went to Raytheon, and I don't know whether I should say I learned how to program or I learned how not to program while I was there. I did some good work, I hope, and made a lot of good friends. Some of them I'm still in touch with today. And I started to teach classes while I was there, and I enjoyed that too. That led to some more opportunities.
Now, not being a CS guy, was there some shock in what the heck is source control and that sort of thing?
Yes, it was tough at the very beginning. Everybody seemed to know everything but me. It was like my undergraduate year all over again. I don't know what source control is. I don't know how to exit from VI. Everybody seemed to know everything because they had come from a CS background and I had come from more of a pure science background. But I think that I was very well prepared for engineering by doing the pure science first because it gave me a way of thinking about problems that I think in the long run was an advantage. Even if in the short run, I still couldn't close a VI editor, although sometimes I still :WQ in Word. I don't know. So there's a lot of muscle memory there in my brain. If you look at things from a physics point of view, what is a good system? What is a robust system? Well, you want to minimize the entropy of the system. That is, you want to have the number of accessible states that a system could fall into be very small. That's a physicist's way of looking at it. I can remember I shared a cubicle with an electrical engineer at Raytheon for some of my time there. And in those days, we didn't have the Cat5 cables. We had these coaxial cables that we sent signals to computers through. And the terminator on one of those cables got lost and nothing worked because without the terminator on the end of those old coaxial cables, there was all kinds of reflections and problems. And so my electrical engineering cubicle mate said to me, hey, wanting to impress me, hey, do you know how the terminator on the end of one of these coax cables works? Coming at it from a physics point of view, I said, actually, I do know how. It makes it appear as if the end of the cable is infinitely far away. And he put on his electrical engineering hat and he said, no, that's not what it is. He paused and he said, oh, no, wait, that is exactly what it is.
Like an attenuator or
yeah,
something?
he said, you don't think about things the way I think about things, but you get the right answer.
That's funny. So there was a prediction made way back then too by a Nobel Laureate, right?
That's right. It was in Physics Today, and I wish I could remember which physicist it was, but he made this prediction that what's going to happen in the 21st century. And his prediction was that in the 21st century, computer science will be recognized as a subdiscipline of physics. Like we have cryophysics and we have astrophysics. Computer science is going to be recognized as a subdiscipline of physics. And that's a good prediction. But, Niels Bohr said that the opposite of every good idea is also a good idea. And maybe what's actually going to happen, I think, is that physics might be recognized as a subdiscipline of computer science. Maybe the best ways to describe the world aren't going to be continuous equations. Maybe they're going to be little discrete programs. We'll see.
You are listening to the Underserved podcast. Underserved is produced by Syrinx, the developer-founded, developer-run software consulting company. For more information, visit syrinx.com. That's SYRINX.com.
So did you teach at St. John's after that?
I did. I taught at a few places. I taught adults computer programming at WPI and Northeastern, and I also worked full-time as a teacher at St. John's High School in Shrewsbury, my alma mater. I really treasure those years. It was really wonderful to have that experience, and I kind of miss teaching. I kind of miss that aspect of it.
What is it that you liked about teaching?
Mostly when somebody gets it, when someone's struggling with something and then they get it, and you have a small role in that, and they feel good and you feel good. There's an emotional reward that comes from that. And I really enjoyed that aspect of teaching quite a bit.
And then you were at the Soma Group after that?
That was a consulting company. We did software. We wrote code for semiconductor fabrication equipment. So all of the wonderful computers and chips that we have, they have to get manufactured in these gazillion-dollar plants that have all these pieces of equipment in them, laser cutters and ovens and all kinds of different things. And we wrote software, often embedded software, that guided those machines. And I have to say that experience with consulting was wonderful because I saw a lot of really bad code. And I learned a lot from that. I learned, there's so much out there to know. There's so much out there to learn. And I worked with some great people and did some fun projects.
I often say that consulting is kind of like dog years. You're going to be at several different companies, seeing the best and worst practices and figuring out what to keep and what to discard when you move to the next client.
Andrew, that's so true. I agree.
So were you doing like waterfall type stuff, agile? What did the development look like?
Well, there was a mix, as you say. It depends on the company. I think that for some of the big defense contract stuff, a lot of that is waterfall that I had done. But you have to be, even if we didn't use the word in those days, you have to be agile when you're in consulting. You have to respond to changing business needs. And I feel like even if we didn't use that word, there were elements of the agile process that seemed to come naturally to us.
What sort of things did you find yourself doing that would be maybe lowercase a agile?
Well, we didn't call it this, but we did pair programming. And it wasn't something that I always necessarily enjoyed, but one of the important roles that you have as a consultant is knowledge transfer. And sometimes that knowledge transfer goes from expertise in the language or the operating system toward the person that's hiring you. And sometimes that flow of information goes from domain expertise back to the consultant. And without using that word pair programming, there was a lot of time spent at the keyboard, at the whiteboard, and that kind of cross-pollination was necessary for success.
And then after that, you ended up at AP Engines?
Yeah, that was a .com era startup. Met some lifelong friends there. That was my first time programming in Java on the JVM. I learned that, some of the things that I cared about when I was programming in C, memory management and these kinds of things, maybe I was spending too much energy solving the wrong problem.
They were overrated.
Exactly.
And so what were you building there with Java?
So if you could imagine, if you had, going back to the earlier days of the internet there, if you could imagine one company that owned content like movies and another company that owned the pipes like an AOL, and a Time Warner that might own content and an AOL that might own or have the ability to send data through pipes, they might have to work together so that any movie could travel through any internet service provider. And what we were doing is we were writing code that allowed that kind of interoperability that was necessary for things like, Sherman antitrust to pass, stuff like that. So we felt very valuable. We felt like we were really helping.
And what did you like most and least about Java back then?
What a good question. I think what I liked least about it is what I still like least about it, which is the verbosity. It has all the defaults wrong, I think. Java is perhaps easier to read in some ways because it's so verbose, but it's a little frustrating to write. So that was something I didn't quite care for. Something that I liked about it is it allowed you to focus sort of more on the domain problems and a little bit less on the technical problems. You didn't have to worry about freeing what you malloc, for example.
And then from there, you went to Motorola?
Yes, there was a company called Broadbus that Motorola eventually acquired. And if you can imagine, if you remember what a TiVo is, if you can imagine having a gigantic TiVo on the other end of the cable pipe, instead of having the disk drive and the box in your own house, it's remotely done, sort of in the cloud before we used the word cloud. They built proprietary hardware that was like gigantic TiVo boxes that you could use to rent movies, stream things, and did a lot of SOAP and Java and a little bit of Corba and C++. It was interesting, I temporarily left Broadbus in the middle of my stint there. The startup was hard work and I wanted to try something else. And the funny thing that happened was I had found another role. I accepted this other offer and I went into my boss's office at Broadbus and gave my notice and said, sorry, it's been great. Enjoyed the work, but I'm going to try something different. It was in a different industry, different field. And literally as I'm walking out of my boss's office, my cell phone rang and said, oh, that offer we just gave you, we can't honor that. We've had some changes in structure. And I said, oh, I just literally walked out of my boss's office having given notice. And so that was kind of a jolt to kind of an experience for me that maybe I've learned a little something from.
The exploding offer.
The exploding offer. So I wound up going back to Broadbus, and I'm very glad that I did. I really like the people there and the work.
What were you doing with Corba there?
So that's a very interesting question, and there's probably a technical lesson in there. Corba is a way for different programs to communicate with each other, and Corba solves some interesting problems for you. It allows programs that are written in different languages to talk to each other. It allows programs that are running on different operating systems to talk to each other, and it allows programs that are running on hardware with different endianness to talk to each other. Those are the three reasons Corba exists. And we were using Corba for C++ programs running on Unix on the same boards to talk to each other. In every way, it was the wrong technical choice, right? But I knew Corba. And so when I was interviewing there, they said, oh, we need somebody who knows Corba. And so, when I got there, I kind of thought, I don't think you want Corba, which wasn't probably an answer anybody wanted to hear. But I was glad to have that skill because it got me in the door and got me the job.
You had a good quote when we talked on the pre-call that the tech skills we bring to the table are often not enough alone.
Yes, it's not enough to be right. It helps to be right, but it's not the technical skills that sometimes make the big difference. When we were using Corba lives by sending messages into big queues, and the messages get honored and serviced. And what we were finding is that, around 8 or 9 o'clock at night, when people came home and fired up their TVs, our system would sometimes get overwhelmed and the queues would fill up in the system. So the first thought everyone had was, oh, let's increase the size of the queues, which worked for a while, but all we did was we just created these gigantic capacitors in the system that would just discharge and create a lot of chaos. So I said, no. It's tempting to want to increase the size of the queues, but the right thing to do here to diagnose the problem is to shrink the size of the queues to make the problem happen faster so that we can identify the proximate cause. And the problems that I faced was it's hard to convince people to do what seems like it's the wrong thing. It required some schmooze, and it required a little bit of political skill that I hadn't really developed yet to convince people to do something that sounded like it was the opposite. And it was sort of that human skill that was responsible for us to solve that technical problem. So after a while, one of my buddies started calling it Morgan's Law, that, when you run out of a resource, shrink the resource. So that's Morgan's Law. That's how you find the problem. So I was at least pleased that I was able to convince people to solve the problem, but it took more than technical know-how. It took persuasion.
Thank you so much for joining this Zoom panel interview for our software development position. My apologies for having to reschedule it 7 times.
Hey, no worries. Ready to get this underway.
Let me introduce the panel members from our company. First is...
Whoever that is, can you please mute?
Sorry, that was me. Mailman's here.
Hey, you guys hear me? You see me? My kid is playing Fortnite and my bandwidth is sapped.
Hey, sorry, I was on mute. Hi, this is Connor Walton.
Can everyone who is not talking please mute yourself?
Sorry, so where were we?
Yeah, so the main reason I joined was to let you know that I accepted a job offer from your competitor this morning. Sorry, your process just took too long. Laters.
Does this drill sound all too familiar to you? If so, you should call Syrinx. Syrinx helps you complete your projects on time and on budget. So stop the Zoom calls and start shipping code today. Call us at 888-579-7469 option 1 or email us at sales@syrinx.com. That's sales@syrinx.com.
Well, I think you capstoned that segment by saying soft skills allow you to exercise your tech skills.
I think that's true. I think that we don't work in a box somewhere. We work with other people, and it's the ability to convince people to let you try things, sometimes make mistakes, have some latitude that gives us the resources to solve a problem. So I think I might have tried to say something wise when I said that.
So I am completely unsurprised that after AP Engines and Motorola and working on all of this delivering content for cable providers through pipes that you ended up at SeaChange doing some work there.
SeaChange is in the same domain. And it was funny, when we left Motorola, there were all kinds of contractions. And I can remember there was a meeting where we were all called in and we were given a PowerPoint presentation. And the first slide was, everything's great, we've got a huge market. And the second slide was, well, but there's some competitive pressure. Then the third slide was a little bit worse. And the fifth slide was, so consequently, everybody in the room is laid off. And we all looked at each other and said, we just got laid off by PowerPoint, One of my friends turned to the boss in the room and said, hey, I really liked working for you. I hope that you'll be a reference for me. And the boss said, did you miss the part where I'm in the room with you? I hope you're a reference for me too. So a bunch of us did wind up moving over to SeaChange. And that was very nice. It was a similar space, and I feel like I learned a lot there too.
What was the technology stack similar? Or?
It was not that similar in the sense that we did a lot of Java at Motorola and Linux, and we tended to do more .NET at SeaChange. But I was able to bring over some skills. We were using JUnit in one place, and so I introduced people to, NetUnit in the other. And I hope I helped improve some development practices that way.
Introducing good unit testing is usually a level up. So did you do some consulting after that?
I did. I found it really painful to throw yourself into a company and then be separated from it. And I said, I don't want to go through that again. So I hung out my shingle and did some consulting for quite a few years. I had worked with enough people over the years, and apparently I had impressed them enough that I would call up some friends and say, hey, I'm a hired gun. Is there work that you have for me? And often someone would say, why, yes, come work with us. So I worked for a variety of different companies that way, calling up friends and coming in, writing everything from JavaScript to .NET work, a lot of Java. And that was really nice. It was a good chance to see projects at all different levels of their development. At the beginning, when you're shipping, the development work, and moving from place to place, as you said earlier, you can be a bit eclectic. You can learn, take the best from each one and add that to your arsenal.
And is that around the time you discovered Scala?
It is. I describe learning functional programming or discovering functional programming the way Dorothy in The Wizard of Oz left her sepia-toned house and stepped out into Technicolor. I had no idea how much I didn't know. And having done imperative programming for so long and not having had a formal training in computer science, discovering all of this functional programming out there was really eye-opening and wonderful. I realized how much cool stuff there was that I didn't know, how interesting and mathematical it was. And a friend, Nerman, who I met through the Boston area Scala enthusiasts group, said, "Hey, let's teach a class together," after I had given a presentation at the group. And so we had a wonderful time. We taught a course in parallel programming and concurrency at the Harvard Extension School. And I really enjoyed that experience. If there's any way to learn something, it's teaching it. So that was a great way to learn Scala.
Now, you came from an OO background. I imagine you've implemented every one of the patterns from the Gang of Four book. What was it like with the mind shift from heavy OO to functional?
Yeah, the Gang of Four design patterns book has to be the most ironic book ever written. It's a catalog of how to use inheritance to solve every problem that you can think of. And yet in the introduction to the book, it says, prefer composition to inheritance.
That was the best part of that book.
Yeah, that was the best part. And I've now come to understand that design patterns like that are really language deficiency compensators. If you have a language that, say, lacks lambdas, then you're going to need the Gang of Four command pattern. If you have a language that lacks some other feature, you're going to have to figure out a way to implement it using the features of the language, which are maybe inheritance. And it would be much better to have a growable language where you have the features that you need and you don't have to discover these arcane patterns to compensate for the language's own lack of richness.
For folks that aren't familiar with Scala, can you explain what a lambda is, for example?
A lambda is like a function pointer. If you're familiar with function in C, that function can have an address and you can pass that address around and say, hey, execute this function. Native language support for that kind of behavior is going to be found in a lambda. They've made their way into other languages now, like Java 8 anyway, and they make the language richer and more expressive. And it's something that you can find, even if you go back to a Unix system call to sort things. One of the arguments to that old Unix system call to sort things is the address of the function to compare the elements to be sorted. So that's a kind of lambda that's a little bit awkward to use. But think of how your mind changes if you have a vocabulary to express that idea very naturally and start talking about lambdas. The programs that you write are going to be different and maybe more expressive. This was the kind of Technicolor explosion that happened to me when I started to learn functional programming.
If it's a pointer to a function and it could be pointing to potentially several different functions, do they all have to have the same arguments so that the stack matches, or?
Yes, you're describing concerns about strong typing there. And I have to say, I'm very much a fan of strong typing. I've programmed in looser typed languages like JavaScript, but I'm a lot more comfortable when I can get the compiler to check things like you just described for me. It's a unit test that I don't have to write, that the compiler is executing. When I was at Raytheon, I wrote Ada, the old Defense Department language, which is very, very strongly typed, and that probably warped the deep structures of my brain. And it makes me prefer language with a good type system that will have all kinds of good checks in the compiler and have me be very suspicious and nervous when I have to write something in maybe JavaScript that doesn't have those same guarantees.
When I first started doing JavaScript, I felt the exact same way. I was coming from C, C++, and Java, and then starting to do a bunch of JavaScript. I was like, ugh, everything's an object.
Yeah, I see that there's an elegance to JavaScript. It can be a very enjoyable language to program in, It might be a matter of taste as to whether people like the strong typing or the weak typing, but at this stage in my life, I'm more on the strong side.
Now, how does a Lambda help you avoid having to implement the command pattern or something like that?
That's a great question, Andrew. So when you want to vary things that are executed by one algorithm or another, right? So here's a thought that just comes to mind. So suppose you needed to sort things and you need the ability to sort a bunch of things. You could say, oh, well, I could write an insertion sort that has very nice properties for how long it'll take. But why would I ever not use an insertion sort if it's the best? Might I want to substitute in a different kind of sort? Well, actually, bubble sort is almost linear if the list is nearly sorted. Bubble sort outperforms the so-called best sorting script. So maybe there are times when you want to swap a different algorithm in. If you are doing object-oriented programming, you would need some kind of a strategy pattern or some kind of a command pattern that allows you to use inheritance to swap out one sorting algorithm for another. So you've got to make a class, you've got to inherit from the class. Okay, now I've got all this code, I've got a lot of boilerplate. If instead I just have a Lambda, there's a whole bunch of cruft that I don't have to write. And it's easier on the eyes. It reduces the cognitive load, I think, and it allows you to spend your precious neurons solving sort of the business aspects of the problem rather than the syntax problems of making this class and this inheritance. Just go right for the language feature that supports this variation in algorithm.
I come from a Java background. It sounds like, as you're describing it, a lot like an interface or something like that, as opposed to a class that you then have to subclass. Is that close or far off?
I think that's close, right? If you think about a method in an interface, then that method is going to have a domain, like a function, a set of inputs. It's going to have a codomain. It's going to have a set of outputs. So that interface is going to define the types of what's allowed to be passed in, the types of what comes out, but it doesn't necessarily specify how that transformation happens. So a Lambda is like a method in an interface. It has type of inputs, a type of outputs. In math, we'd call those a domain and a codomain, but I could have different implementations.
Now, I think you mentioned you met Nerman at the Boston area Scala enthusiasts group.
Yes.
Are you still involved with those folks, or?
You know, when the world changed a year ago, a lot of these abilities to get together was really adversely impacted. And I'm looking forward to, renewing a lot of those in-person friendships as soon as we're able to. I've really missed that kind of in-person contact.
Did you do some teaching at Harvard Extension School when you were teaching Scala?
Yes, exactly. Nerman and I were co-instructors. We taught class on parallel programming and concurrency. And it was just a wonderful experience to go back, to actually teach in the same building that I had taken classes from. It was a really warm feeling, and I'm grateful that I had that chance to do that.
I never went to Harvard as an undergrad, but I did take some extension school classes, like right after I graduated UMass, moved out here, was working at EDS, and every one of them, the instructor was just top notch. And I was like, wow, this is really awesome.
Well, I'm going to interpret that as a compliment. But also, it's not just that there's great instruction. The students also really want to be there bright, and that makes the class. If you have enthusiastic people that want to be there, that bring things to the table, that creates such a wonderful dynamic in the class, greater than anything that a teacher alone could produce.
So tell me what you've been up to since you joined us at Syrinx.
Well, I feel like I've come home. I'm glad that I've pulled in my shingle. I have been doing some Spark programming in Scala, a lot of big data, and work with a great group of folks. And the work is interesting and challenging. It's everything that you could ask for. It reminds me of a time when I worked back at Broadbus and Motorola, and I can remember grousing about something wasn't working and something wasn't right. And my friend Shane, who was not a programmer, but who was absolutely essential to the company, doing all kinds of important installs and important hard work, he said, you're a programmer. You create things out of nothing. You push electrons around for a living. And he said, I wish I could do that. And I thought, oh my gosh, you're right. You're right. I have nothing to complain about. We have great jobs. And, we are literal magicians who can create things out of nothing and solve problems and deliver business value. And it's just a wonderful experience to work with people that are curious and bright. I just love it.
So, Morgan, you have 2 kids. What do they think of what Dad does for a living?
My son is in high school now at my old alma mater, St. John's. But when he was about 5 years old, his teacher asked him, what do your parents do? And he said, well, my dad talks about bugs a lot. I think he's an exterminator. And I just love that, And he's going to be taking computer science this year. He's a sophomore. And I think up until this point, seeing me frustrated with coding and only kind of seeing the hard work and the bad side of things, I don't think he wanted anything to do with programming. But having found this new wonderful role, he's asking me, hey, maybe this is pretty good. And I would love to work with him on some computer science, but to help him get ready for his upcoming CS classes. I think he sees that this can really be a good job and that maybe it's something he'd be interested in.
So the gig you've been working at Syrinx has been more interesting than some of the other grind?
I think he's noticed that I yell at the computer a lot less.
Excellent. Good to hear. Well, we do have to try and pull the next generation in. Someone's got to take over for us.
That's exactly right. And, my daughter's very smart too, and maybe she'll be doing it herself. She's 4th grade, so she's got a ways to go, but I think she'd be a good programmer herself.
You could start her on Logo. I remember doing that in 4th grade.
There is Logo and also Scratch.
Scratch is quite popular. Well, Morgan, thank you very much for coming down to join us today and record Underserved in studio with us.
Andrew, it's been totally my pleasure. I'm so happy to be here in the studio with you. Thank you very, very much.
And we'll talk to everyone soon on the next episode of Underserved.
Thank you for listening to the Underserved podcast. For more information on the topics discussed and for show notes, visit the show website, underserved.fm. And please be sure to rate, like, and subscribe to Underserved on Apple Podcasts, Google Play, Spotify, or wherever you listen to podcasts.